put into the block is going to change the hash every single time. The importance of that is, unless I know exactly what that hash is, there's no way for me to be able to understand what understand what the data is. There's no way for me to be able to unlock the hash and know what's in there unless I have permission. From the hash, we get into what they call the block. Blocks can contain, and in this particular instance is just one set of data, that can actually represent thousands of transactions written to one block. So it's very efficient in the way that I don't want to write a block every single time one particular transaction is made. I want to store those up and do everything like a batch process, if you will, at one time, because of how much time it takes for the hash for it to hash cryptographically and put everything onto the block itself. I want to give it some time. The nonce, that's the number of times that the software had to go through before it was able to find a unique hash. That's also called the statement of work, or the proof of work. So that's where the fees come in. So once everything is written to a chain, you can see here that we've got a chain of items now. So now we have a blockchain, and we've got 5 blocks written on the chain. What's important that I want to point out here is previous is all zeros, because this is what they call the Genesis block, the very first block on the chain. But over here, you see that it's got the previous hash here and here, so it knows who's behind it, but it doesn't know who's in front of it. And so I'll let you start thinking through the different possibilities on the cybersecurity side. If I'm able to hack into block number 2, I still don't know who block number 3, 4, and 5 are. All right? Some very key things in there if y'all ever want to look at this from an implementation perspective.
But you know, the Klingons are going after the Genesis block, right?
That's true. So what happens if I change the data here? Everything, and I don't know if you can see back there, but the color changes from green on this one to red on this one. And now you can see that everything in front of it has changed because the hash changed, because the data within the block changed.
So now it's changing retroactively then on the block.
Correct.
And nothing in front of it has changed, just when you make a change in a certain block, everything prior to it changes.
No, everything prior to it stays the same. It's everything forward that
Forward
breaks.
changes.
Right.
So how do you maintain auditability, now that you've changed everything?
So this is where the consensus comes into play. So number one, and you can look this up, it's called fork, F-O-R-K, just like silverware fork. This is what happens whenever you have a fork, which Ethereum has already had because of the hack that they had. And there was one, actually Bitcoin just recently did one as well. So whenever you do the fork, everything going forward is going to be okay, but everything behind it becomes a legacy network. And so it's up to you if you're going to keep it or not.
So if
Now,
you see a fork in the block, take it.
Depends.
Depends.
Depends, because depending on who it is, with Bitcoin, they went to Bitcash, and that wasn't a good fork for them because the adoption for Bitcash didn't take off like Bitcoin did. So it depends. But here what I would have to do, I would have to remine in order to fix that block, and I would have to do that for all the consecutive blocks as well for it to be fixed again. So as you can imagine, right now you've got a little over 4 million blocks that you're dealing with on the Bitcoin side of things, or nodes. Now, within the nodes, you've got, I want to say it's right around 12 terahashes a day that are happening. So now you can kind of get a perspective of why you don't want to do this. Because if you're doing 12, just think about 12 terahashes a day. Now, if I break one in the middle, every one of those after is going to have to be remined. It doesn't sound like a big deal, but it is a big deal whenever you consider how much compute time and power that it takes in order to do a mining. Now, this is a demo, so it only took just a couple of seconds. That's not the case whenever it's in the real world use.
Kurt, I was thinking, if we're getting into more technical,
Okay.
I'm sure there is a lot to talk about hashing and all this, right?
Okay.
Then we want to compare with the, Ethereum. I mean, this is
Ethereum.
Ethereum. This is on the Ethereum stack.
This is just blockchain.
This
Yeah.
blockchain, right? So there is something to compare with,
Mhm.
right? So do you mind continuing on the same thing maybe next week? I'll give you another
We can do
30
that.
minutes slot. so that you have a lot to cover actually.
I was gonna say, yeah.
You know, it's an
it's
interesting
tough.
topic and people have questions,
Right.
definitely. And I'm pretty sure Luke wants to have his own, you know, spin on that, so, if you don't mind, what do you think? I mean, is that okay?
It's your class.
No, I mean, for you, would you like to come by and share
Yeah.
this with the class?
Right, actually.
Is that, what do you guys think?
We want
Yeah.
to.
Is that a good idea? Oh, sure, great. Take some questions, by all means, whatever you covered so far.
Sure. Any other questions?
You said that there's a place where we can go and look at these demos,
Correct.
and you're gonna give us that website?
I was gonna say, can I send it, because I'm not on the distribution list, so.
Send it to me, yeah.
Okay, all right, I'll send it over to Deb, and that way,
Perhaps
there's
your
3 different
slides
demos.
Or your slides proprietary?
Yeah, no, they're not proprietary, yeah, not at all. Actually, the graphics that are, they're not.
All this open compute that's occurring, where is it actually, like, if you take this infrastructure like Google, is it across, I know blockchain is spread across, but where is the compute occurring across? Everybody, the transactions will be the systems or the cloud, or who's providing the infrastructure for blockchain?
So that's actually a good question. In some cases, it's people themselves that have virtual servers within data centers. So I can have my own private blockchain, or in some cases, you've got blockchain as a service, which Microsoft has a blockchain instance on Azure. We've got, IBM has Hyperledger on theirs, and there's, I'm trying to remember the name of the one that Amazon, on the AWS side. But there's a lot of them that are blockchain as a service, if you will. So there's still a private instance, but it's on a public node, if you will.
Okay.
So,
But then the public knows the problem is, if you talk about the terahash, the generating the hash takes extreme compute. Who is paying for that? That's why the fees of Bitcoin is so
that's
high.
exactly right. Now you start seeing, so that's actually a good point, and I'll bring that up just briefly if that's okay, because,
Don't buy Bitcoin, by the way. Right now it's crashing.
yeah, listen to him. The one thing that I would say on the no fees, be very careful, because just as with anything, there's a lot of marketing that's going on right now. And there's a lot of different network models that are coming out. Anything that's public, there's a fee somewhere. Now, most of the time, it's not a transaction fee like it would be with a credit card, but the fee is actually that you're having to pay for your server to compute all the hashes going forward. So you're paying for usage time in the cloud, if you will. So
But
there's
if you
still
go
a
to
cost.
Coinbase or, any of those exchanges, they just say exchange fee, but, and the exchange fees are ridiculously high for
Especially
Coinbase.
on Bitcoin.
And they're not FDIC insured, right? So
No,
No.
it's SaaS.
No government ownership.
No government.
they don't want to have that effect.
They're trying. FDIC doesn't want any part of it, but SEC does. So SEC and IRS are both heavily in